So variable acceleration now. So we can't use suvat anymore. It's calculus. Let's see how this one goes. So what are we trying to do? We're trying to find the possible values of k, the k here. And we are given that when t is 2, the speed of p is 10. So we better find an expression for the speed of p. Well, we know the position vector of p, so to find the speed of p, we differentiate. So v is dr dt. We're finding the velocity here, firstly, not the speed initially. So when we differentiate these two things, we get 3t squared minus 10t as the differential of that, and 2 plus kt squared as the differential of that. So the speed is the magnitude of this velocity. So using Pythagoras, the speed is this. And we know that when t is 2, the speed is 10. So putting 2 here, here, and here, and making that equal to 10, we get that, which simplifies to this equation here. And what we can do is square both sides. So that would be 100. Take the 64 over, and that gives us that. Square rooting both sides, and remember that the square root of this is plus or minus 6. We find k has got two values, 1 and minus 2. So we found the possible values of k. Now what we've got to do for each value of k, find the acceleration of p when t is 3. The acceleration is the differential of velocity. So where's our velocity? There's our velocity there. We're differentiating that. So there's our acceleration vector. And when t is 3, so when we put t equals 3, we get that vector there for the acceleration. And so when k is 1 and k is minus 2, the accelerations are those two. Okay, so then part C, for the larger value of k, so that's k equals 1, find the magnitude of the force that's making the particle move. So if we find the magnitude of the acceleration, we can use F equals ma. So when k is 1, the modulus, or the magnitude of the acceleration, is the magnitude of this vector. Using Pythagoras again, we get the magnitude of the acceleration as 10. And using F equals ma, knowing that the mass is 4.5, we get the force of 45 newtons. So there we are.